Hi everyone and welcome to a video after so long. In this video I'll be going to discuss the forward algorithm that we have of Geoffrey Hinton. Obviously I have read this, you can say 3 times, like 2 times very properly, 1 times half. I'm not going to talk about the detail how this paper is designed and wrote, because I will link a very good video in the description that talks about it very properly and probably with more amount of experience and knowledge than I have in this field. And I would just like to pinpoint the specific things that I have written down from myself, like after 2-3 iterations, so that you can get an overall generalized view. I specifically want to talk about this algorithm because the people who think that OpenAI GPT-4 is a great invention, no one can be any more wrong than them, because yeah, I get that it's one of the greatest leap for humanity with respect to AI, but this is the actual thing. Not going with respect to the call for authority as it is said in that video, but just by the sheer quality of the thought and things that has been written in this paper, it's an extremely great paper. This thing is laying down the foundation on which the future GPT would be based on. This should be more celebrated and published and read and worked upon, because it's a great thing, and working on this could only lead to a proper future as per me. I have read a lot of papers having a lot of new and good ideas with alternatives of backpropagation, but they are not as good as this, because again, not because of Geoffrey Hinton, but because of the density and inspiration of human brain, the reflection of evolution. It is such a good thing. So this is also why this should be worked upon and celebrated even more than it is already being celebrated. This paper was extremely dense. Each and every segment has a whole different possibility, future and paradigm. I read this mostly from a philosophical background, mostly from a philosophical point of view, because I thought that could also be one of the greatest way to appreciate this paper. There is this concept of model computers as well that has been introduced and worked upon this paper, but it is in very brief, and for that I would like to make a whole new video in which I would also like to add some of the things that I've been working on in my CQB and I have worked on in DSW, and I would make a whole collection of all those thoughts, and I would like to make a separate video for that. It's just a small paragraph in this, but again, as I said, this paper is so dense that even a small paragraph can be expanded as however long you want. Before starting, let me try to summarize the things that could be relevant to anyone who is listening this who does not have a strong AI background. So basically, currently at this time, the AI is basically all driven by machine learning. Machine learning is driven by deep learning, and deep learning is basically driven by backpropagation. There is this reinforcement learning that is a bit different from the machine learning, supervised and unsupervised learnings, and that is why there are basically 2 fundamental approaches to AI thing. Again, you can see infographics on your image screen. The one in which we learn by examples, and the one in which we learn by experiences. In reinforcement learning, we learn by experiences, and in backpropagation and machine supervised and supervised, we learn by examples. So backpropagation is basically saying that let someone do a thing, and then after they do a thing, say that no, that's not how we do it, you did it wrong, and then they try to improve themselves by going back to their processes. So first they do a thing, forward pass, and then you tell them it's not correct, and then they improve their work in the backward pass. This is basically backpropagation. In the forward algorithm, the basic concept is that you don't tell someone what is wrong after they have done the mistake. You tell them beforehand only that don't do this mistake. And Geoffrey Hinton tries to put this in using positive and negative data, that is good habits and bad habits, you can say. You have to tell a person what are good habits, what is good data or positive data, and you have to tell a person what is bad habit or what is negative data. One other way to put this backpropagation and forward algorithm in a single sentence is, let's say you want to teach a child follow some manners. So let the child do things on his own, in his own ways, and in the end you tell the child that these are good habits and these are bad habits. Then the child will backpropagate that and learn, okay, these are good habits, we need to do this, and these are bad habits, we are not required to do this. But what Geoffrey Hinton said in the forward algorithm is, these are good habits and these are bad habits. Tell the algorithm and model in the starting only by using good data and bad data in a way. So the algorithm learns how to do the good habits or to work with the positive data, and how not to work with the negative data. Instead of telling in the end that this was wrong, tell them in the starting only that these kind of things are wrong, so that the model or let's say the child does not do them in the first place. This is basically forward algorithm. I also made some kind of memes regarding this when I reflected it with respect to the enlightenment kind of things with respect to Hinduism and the things that I know of Bhakti Yoga and Dhyan Yoga, that you can again see a meme on your screen. Not going to the segment that how it is a lot similar to the things that I wrote in my DSW and that I wanted to portray in my DSW in various ways, and also the kind of similarities that it already has with the current work that I'm doing in my CQV. But because those things I don't want to bring them here, it is about Geoffrey Hinton's forward algorithm, and I think we should celebrate that. I was about to trim my beard right now, but then I thought it would be weird to record a middle segment in which I don't have a beard, so let us just continue. So yeah, one of the basic things that I can think with respect to these two algorithms, forward and back propagation, with respect to philosophy, is regarding how justice system works in a democracy and how job hiring is done. So basically the back propagation worked on the concept of minimizing the loss function or the badness in a model or in prediction. But the forward works on maximizing the goodness, or the actual term that is used is also the goodness in the paper. So these two are actually the approach for the same thing. They both bring the same result in the end. But one is like minimize the bad thing, and obviously if you minimize the bad thing in a system, you are trying to maximize the good thing. But the focus with respect to the forward is not to minimize the bad thing. The focus in the first place is to maximize the good things. To see with respect to the democracy, then as far as I know, not a good democracy or politics guy, but as far as I know, that there is this rule in justice system that one innocent should not get punished even if we have to let 10 guilties go away. So it is similar to this. Forward is similar to this in a philosophical, in a base way. And how job hiring works, that you should not have one bad hire even if you have to let go 10 good hires. So that is basically back propagation. They both are very much in a philosophical way, in a fundamental way, related to these two concepts of two algorithms, but you'll have to draw a lot of connections to properly be able to see it. I won't be going into that because it will make the thing wrong. But yeah, it has a lot of implications from the fundamental way of seeing, and I think it is extremely good on the other way, because if we use forward algorithm, then we will not have to make things to regulate things. Like the goodness will be inherent to the models. We'll not have to make rules to govern the goodness or badness of a system. So coming to the 11 points that I really want to talk about, here are the points. Let me start. First point and the last one at the same time, because I will, in the end, you will see how this point is extremely relevant in the context of the forward algorithm. Overall, great work to extract and use wisdom and knowledge of year-long evolution in form of human. Truly inspired and not copy. Perfection is an illusion, so Oracle can go fuck itself. That is, it can work with black boxes in forward pass while training. So black boxes were one of the major problems with back propagation. It does not work. This is one of the general saying that Oracle, or a perfect example, a perfect forward knowledge, you need that for back propagation to work. But that's not the thing with forward. It can work with black boxes. It does not need anything like that. I think this is one of the most strongest part of the forward algorithm. Next point. Forward is best of both worlds, that is back propagation and reinforcement learning, and that is having the scalability factor of back propagation and having the no Oracle benefit of reinforcement learning. So it is like getting the good things of this also and good things of this also and combining it. Not doing it with respect to deep reinforcement learning, how we just shove the neural network kind of things in reinforcement learning. It's not like that. It is like utilizing or getting the extract of both things, like getting the actual good things of both worlds. Back propagation is only fast in cases when power is not an issue. That is a lot of cases. So it is mentioned in the paper, but back propagation is extremely successful in the current world because it is used in a lot of cases, but it is only useful till the time the computation or the power is not a problem. Till now it is a thing, but it has not been an explicit thing, because things like big data and all can be handled with amount of computation we have. But if we move forward with respect to the things that I've been working on, existence and all, or something more than intelligence, then the computation power that would be needed might not be able to be sufficed by the computation power we have of digital computers or supercomputers or even quantum computers. So in that cases, power will be an issue. At this moment, it is not an issue given the amount of tasks we have to do. But when the power will be an issue, that is obviously going to happen someday or other, because power is not free. And then this forward will come into light. That is again going to happen very soon as for me. You can find this in 3.3 section of the paper. Useful in wide variety of tasks. If you see, the purpose of this whole AI game is to make AGI, or everyone is trying to do that at least in some other way. And to do that, one of the things that is inspired by human brain is also not general intelligence. It is also narrow intelligence, but all of the narrow intelligence is combined in a streamlined way. Like our brain has different sectors for hearing, for listening, for processing, for visual. It is not like our whole brain does that in a single thing. Like the processing is done chunk wise, but the chunks are very much coherent. It's like multiple core kind of thing. And all of these cores, all of this multiple processing are done by the same hardware and software, basically are done by the same kind of neuron activities, are done by the same kind of brain, done based on the same kind of energy, and all the processing is done using the same hardware and software, but in a different way. Our seeing or visual cortex works in a different way compared to how our listening thing works, but they both work using the same neurons and same hardware. The desire of humans being to make AGI, I think, would be very much sustainable with this forward algorithm. Fifth point, only feed forward. What is learned in later layer cannot affect earlier layer. In this paper, it is written that it is one of the flaws or things that is not good with this forward algorithm, to tackle which the video method is being used. But I don't think it is actually a flaw. I think this is where I disagree with paper somewhat, because they think that this is also this can be seen as flaws, and to improve this they are using video things. But there could be a lot different and better ways to deal with this without even using the video ways, and to not just deal with this or not to treat this as a bug, but to treat this as a feature. It can be seen with respect to having bad learning. If something is learned badly in the future, it will not affect the earlier layer thing. So it has a lot of feature set also, this way of working. Next point, 3.5 section, crucial to use negative data rather than internal representation. Again, as I'm saying, this paper is very dense. Each and every segment has a whole new branch that can be explored and made. Okay, this line is just enough explanation, but I think that it is very crucial to use negative data, let's say, to tell someone that it is a bad behavior, instead of just doing the representation of this as it is done in the backpropagation thing. So it like properly understand the human brains in a lot of ways. I don't think I can explain this point much more, because it was already very much clearly explained in the paper and in the video, and it is extremely well put out how it is extremely crucial to use negative data. Coming to 7 point, negative data can be generated in sleep phase, that is not training. I cannot explain the importance of sleep because it is explained by a lot of people in a way better ways, but sleep is extremely important for the human form, and the concept of sleep being introduced in a such a way that in spite of being slept or not being active with respect to training, the model is still doing something for its good. It's not learning, but it is generating the negative data. That is also for its good. Again, something that is done by human as well, except for the Doctor Strange thing. So this is again a great way it has done. I just cannot explain how great this is. Most of the points, they are just great. I cannot like what to tell. It's just great to do that. Like how negative data can be created. The thing that is one of the important thing that we face a lot of problem with respect to data sets in the current machine learning models and all. But in this case, it is generated in the sleep phase. You are not required to go and hunt for negative data. You can just generate it from while you're sleeping, while the model is sleeping. So yeah, problem solved. Point 8, segment 5.3. Many different sources used for interference and activation similar to blockchain. How some kind of democracy is kind of introduced in how when a lot of things will agree to the concept, then only the neuron will get activate, and based on interference, how whole value sums up, it either goes to 0 or goes to 1. This is again a great way, and I think some kind of blockchain technology can also be used in this thing to even make this thing even more reliable and safe at the same time, so that there could be no false activation or wrong activations of the neurons. Also, it based on again the human brain mechanism. If only all of our mind will agree that this is fact, then only we will accept this as a fact and reality. So just a great way to do that in technology. Next point, learning fast and slow, like knowledge and realization. Again, this was such a great point, and I can see a lot of reflection of this thing in philosophy and the thing that I'm working on. But yeah, consuming the whole backpropagation as a black box and quickly to adopt the new data using outer loops. It was such a great way. And again, how human society works in general, how teacher and student concept works in general, guru and CC concept works in general. It's like backpropagation could be like some guru who has learned some things, and this forward propagation can just engulf it and learn everything from the from the black box of the backpropagation technique without even having to do anything, because again it can deal with black boxes very easily. So again, it can also learn on the fly, on the go. It's not like you'll have to get data and stop and learn and then you can go in action. It can just be in action, take data, learn, be in action, take data, learn, online, if you want to say. So just great way to do it. The paper is dealing with a lot of fundamental problems, not just of human and human philosophy, but how the human works collectively in a society, and this collective consciousness kind of thing that humans do. That there is not just a single human with some intelligence, but a lot of humans with some bits of intelligence, having in their bits of chunks of memory in their own brain using different parts, and all of these chunks come together to form a human, and all of these chunks of humans come together to form a society, and how all of these chunks of society comes to form the humanity. So it is kind of working and activating and using all of these concepts at the same time. Low-end hardware like brain, low-end hardware and avoiding edit conversion. So in the end of this paper, it also talks about how low-end hardware are one of the better ways to use it, and what can be a low-end hardware except for the human brain. I mean, not with respect to processing thing, but the amount of resources it needs, 3 or 4 spoons of sugar, if I'm not wrong. So such a low consumption hardware, I should say, not low end hardware. This thing of our algorithm can also work on low end hardware, similar to how all of our consciousness and all of our self work on a low end hardware of our brain. And one of the best thing that I saw in this, again similar to human brain, is how it avoids the AD, or analog to digital convergence, and it just bypasses that by keeping things in analog and keeping things in digital and converting only when needed. Similar to when it comes to our brain, how to similar to avoiding thought language conversion in our brain also, similar to avoiding thought language conversion while thinking and meditating at peak. So we don't think in language. If you are thinking in language, that's a slow way of thinking, similar to how if you're working in a digital way, that's slow way of working. And just to avoid that and to having thought in form of thoughts, language are used to represent the thoughts. Again, I couldn't just go and read a lot of meditative things and thinking ways. So to actually think is to think, not to think in a language. If you are using language to think, you are limiting your thinking. Language is just used to organize, use, express, represent the thinking and thought. So this thing is done very well with respect to computers, and this way of low hardware working is extremely done by the forward algorithm. Overall, great work to extract and use wisdom and knowledge of year-long evolution in form of human. Truly inspired and not copy. As Dilip George said, that copying human brain or human ways of working could be a stupid thing to do, because humans are not the most efficient thing. Humans are the most efficient thing for our environment, for our surrounding, but not the most efficient thing for the environment and surrounding that can be in future. So just copying the ways of human brain works would be stupid, and this is what this paper has got very well. It has not copied the way human works, but has got the fundamentals of the human working and functionality, and the fundamentals that evolution used to make humans very well, and implemented that in form of this human body. So this paper has done that extremely well. So I would like to end my video with the thought that it gets more celebration and it gets more worked upon. I know already it has the tag of being written by Geoffrey Hinton, so it will be, but it is one of the greatest achievements that humanity has done till now in field of AI. GPTs and all are engineering thing, but with respect to science and actual work that could lead to potential good future, I think this is one of the greatest way.